Right? So that's the general environment of execution because we allowed concurrent execution and we are executing upon a shared state. So that's the typical problem for critical region in a concurrent programming. So that's exactly the same setup. And workflows may interfere with each other because let's say I have 10 operations and you have 10 operations. It won't be the case that I will execute my operations in a sequence first and then you go. No, it's not the case. Maybe I will execute the first 3 and then you execute your first 2 and then we interleave together. And that's where the interference comes from. And the interference might just update your system state in such a way that all the workflows cannot complete, or at least one of them cannot complete. Or let's say all of them can complete luckily, but some desired properties cannot be established. So we do need a systematic way to calculate the precondition. Okay, so these are the 2 research questions for this paper. The first one is, how should we calculate appropriate guard conditions for workflows, parallel workflows, with respect to either for all of them to complete or for all of them to complete and also to establish something. Second question is, how should we deal with the feasibility of analyzing parallel workflows subject to combinatorial explosion? Let's see how the combinatorial explosion can come into this context. Let's say we have 2 sequential workflows in a simple case. So one workflow has n stages, the other one has m stages. And as we all learned in high school math, how many combinations do we have for arranging all the interleaving orders for these workflows? That will be n plus m spots to choose n spots. A concrete example would be, let's say we have 2 workflows with 10 stages each, and there will be 184,000 interleaving orders for such simple case. So we do need a way to reduce our problem space for analyzing the workflows, and then do whatever test cases we want to generate. So those are the 2 research questions. Our contributions map exactly to the questions we want to propose. So the first contribution is, we have a model-based technique for generating test cases that reflect 3 things. And our test cases are quite in a unique form. So typically, conventionally, each test case should contain concrete data value. But in our case, each test case contains constraint because a certain constraint characterizes a set of possible data values by using some constraint software. Of course, we have seen quite a few papers up to now in the conference. But in my case, we'll just give you a constraint to say, this is a constraint from which you should construct your concrete test case. So we reflect 3 things. So one is the use cases for your concurrent execution. And the second is, what about the data usage pattern? I want to make sure I want to reduce my problem space to only those scenarios for using particular attributes. So this is a technique drawn from data flow testing. I'll give you one example for that. And the third one is the most important thing. I think it's quite unique to this approach. We want to somehow rephrase the developer's implicit intent, because when they were developing the model operations, they do have some intended requirements in their minds. So whatever model operations they have written down, we take that specification and then we somehow try to rephrase it in another form, in the form of constraint. And then we hand this constraint back to the developer and say, do you think this constraint is consistent with what you were originally thinking? If it is, then that's fine. If it is not, then the developer should consider refactoring or fixing their model until the generated test case are consistent with what they were thinking. Right. And the second contribution is about to reduce the problem space of analyzing the parallel workflows by devising some restriction criteria. I'll give you the concrete example for that. Just about, if we have parallel workflow like this, it has so many interleaving orders to consider, but we just want to consider just a subset, substantially smaller subset of that. So we do have a way to specify how to do that. Okay, as I said, this is iterative process. We give the developer test cases, they examine it, they might want to fix the model accordingly, and we will regenerate the test cases for them.